The quickest and most common way to solve these equilibrium problems is by using components of forces and the two equilibrium equations. This problem says find the tension in each bind, so we're going to find A and B. We're going to use these equations, but in order to do that, we have to understand how components work. If there's a force at an angle, so just like this, you would use trigonometry to find the x component and the y component. The x component is the part of the force that runs along the x-axis, and the y component is the part of the force that is on the y-axis. So you can do the trigonometry. Cosine of theta is adjacent over hypotenuse. The adjacent would be x, the hypotenuse would be f. You would multiply this up and you would get that the x component is f cosine theta, and then you would do the same method for sine theta. So the x component of this force is f cosine theta, and the y component is f sine theta. A lot of people say that x is always cosine and y is always sine, but that's not true because in this example, if you draw the triangle and we try to find the x component, you would use the opposite side, and the opposite side is for sine. So most of the time it's cosine for x, but in this example it's sine, so you can't just rely on memorizing it. So now that we have that, we'll start with solving for A and B. There are two forces in the x direction and 3 in the y direction, so I'm going to start with the x direction since there's less forces involved. So in the x direction, there's B in the x, and there's A in the x, but this is positive and this is negative, so it's going to be B in the x, which is positive, minus A in the x. Equal to 0. And then this is the x component, so just put, A and B, and then whatever angle it is. So B in the x is B cosine of 60, and A in the x is A cosine 30, equal to 0. We don't know A or B, but we can solve for one of them and then come back and substitute later. So I'm going to solve for B. This is just the square root of 3. So B is equal to A times the square root of 3. And then I'm just going to move this. All right, so we're done with the x direction, and we'll come back to this later, but we'll also use this. So the y direction is the exact same, but now just using these components in sine. So A in the y plus B in the y minus the weight, because the weight goes in the negative, and the other two are in the positive. And then we could do the component. So A sine 30 plus B sine 60 minus W. So we know B already. So everywhere we see a B, we can put A squared root 3. And then there's only A, so we can solve for A. we know W is 49. So I factor out A. And then I divide to get it all on. And if we plug in, the weight is 49.05. And put this all into the calculator, it's 24.5 newtons. Yeah. So A is 24.5. We can take A, put it back into here. B is 24.5 times square root of 3. So B is 42.5. So the question said, find the tension in each vine, A and B. So we have A and we have B. So we solved the problem. And so I wrote this problem out. I'm not going to go over it, but if you want to go over it, the method would be the exact same. So use these two equations, break it up into X and Y, and then do all the X's and do all the Y's. The only thing that's different now is, like I said, X isn't cosine and Y isn't sine. So try it out and let me know what you got, and I hope this helped.